you start? To do the too early, but no. Okay. Now, we will continue with the slides, but before that, if you remember, we stopped by the Venn diagram. And I'm so sure that you are familiar with the Venn diagram, but let me just simply review it again. We said Venn diagram is very useful. It helps us in order to visualize how the sets are look like, because we said the important formula that we have in the probability is the probability of an event A is the number of occurrence of that event over the ns or n omega, total number of samples that we have. And we said no matter how complicated the formula is, we can represent it in this form. The issue is usually if you don't know what is an A, or it's not easy to calculate what is an A, it's not easy to calculate what is an omega. That's why in probability sometimes you have these form integral summations to be added. In general, we said we can represent any set by using a Venn diagram. Usually we use a rectangle to say that this is omega or S, which is the sample space, and it is everything. Not anything out of this is not possible. So out of the sample space is not possible. Assume that the sample space is, let's say, integer natural numbers. So if these negative numbers are not possible, we don't have negative numbers inside it. Then what we do, we are representing groups with a circle inside it, and we call it like event A. Now, depends in math from what perspective you are looking at this Venn diagram. We can call it a set if you are talking about set theory. If you are studying probability, we call it event A. So you will see that they are all the same with a different name. So we have event A, we have event B, we have, let's say, event C, and we have event E. And we assume none of them is empty. So we assume none of them is empty. The reason that I am representing 4 sets inside the omega is in order to write down some equations and some terminologies. Again, you might be very familiar with each of these ones. I assume you don't know it, so I'll just quickly review it. Now, as you can see, A and B have intersection with each other, right? They have some intersection with each other. And we call it A intersected by B, right? Now, what about A intersected by C? What can we say about A intersected by C? Yes, it's empty. They don't have intersection. They don't have intersection. So, if you remember, can you tell me that now what is the probability of A intersected by C? 0, because it will never happen. Now, because this is 0, what is the probability of A union by C? Probability of A plus probability of C. Now, we said this formula we can represent in a general form. If we have an intersection, like in case of A and B, if we have an intersection, what was the general formula of A union by B? And we said that we are reading it in this form. Probability of A or B happening. This means probability of A and C happening at the same time, which is not possible. But what about this one? What was the general formula? This is probability A plus probability B minus the intersection, because the intersection will be counted twice, so we have to remove it. Of course, we will see in the notes that this formula can be generalized. We can have more than two sets, and we will see how we have to deal with that one. Now, what is the definition of probability of A? We have to look at what is the number of A and we divide it by the number of omega that we have. There are two sets that I have put them in this Venn diagram because we want to talk about them a little bit more in details. And they are set A and E. Set A and set E. What can we say about probability of A in general? What can we talk about the value of the probability? We talked about it yesterday. Yes, it is always between 0 and the probability of omega, which is 1. It cannot be more than 1. It cannot be less than 0. Now, E is always inside A. What can I say about the number of elements of E and the number of elements of A? What can we say about number of elements of E and number of elements of A? Yes, this one is less than or maybe equal to Na. Now, because number of elements is always positive, it means that I can divide both sides by this positive number, so nothing will be changed. And this result, this is the probability of E less than probability of A. And this was very obvious because for any set of E, which is a subset of A, because E is inside A, so probability of occurrence of E cannot be more than the probability of occurrence of A. Again, this was something that we knew. Now, I want to introduce a new way of probability. And before I write it in a mathematical form, I write it in a description form. What is the probability of occurrence of E if we know A has happened? Now, this time, we are not calculating the probability of E. We have some further condition. And the condition says, what is the probability of having E, what is the probability of seeing that E is happening if we know A is happening? And we represent it in this form. What is the probability of having E given A has happened? In this course, this is called bias rules. We will talk about bias rules. We will see how we need to calculate it. I will write down the formula, but we will get back to this one a bit later. And we will actually try to prove it. The formula is the probability of intersection of A and E divided by probability of A. This is the formula. However, this is a special case. Based on this Venn diagram, this is a very special case. Can you tell me, what is A intersected by E? What is the intersection of A and E? If I want to shape it. This is this, right? This is whole E. So it means this is E, so it's probability of E divided by probability of A. It is like N of E divided by N of A, number of samples of E divided by number of samples of A. Now, this means that we can look at this problem locally. For this one, for this question, it is like that I have my sample space to be A, and I have an event E inside it. And what was the definition of probability of E? Number of its event divided by number of sample space. So it's very local. So what I say is very valid only for this type of examples. The general formula is this, but because of the situation that we have in this Venn diagram, we can represent it in this form. Now, let me change the question a little bit and see how we can calculate the probability. As I said, this is called Bayes' rule. You might have seen it, but we will talk about it a bit later and we will show more complicated examples. Now, for the next question, what is the probability of occurrence of A if we know E has occurred, has happened. Now, some of the probability questions, the good thing about it is, if we understand the question without calculating it, we will be able to guess what is the value or what is the range of the value. Now, the question says, I want to know what is the probability of having A if E is happening. Let's get back to the yesterday example when we had the marker. My hand is the sample space. A is picking up a marker. So let me put something else also in my hand so we understand that A is not one. So I have this one. A is picking up one of the markers. And E is picking up a red. Okay, picking up red. The question says, if I have picked up red, Murtaza, what is the probability of picking up a marker? 1, because this has happened, I have it. So what is the probability of having a marker? Then it will be 1. Why it is this, in this form? It is because E is inside A. In other words, if E happens, definitely A has happened. So the question says, what is the probability of A given E? Formula-wise, we write it as A intersected by E divided by PE. Already from before we know that A intersected by E is E. So probability E divided by probability E is 1. Now what was the difference between these two? The difference is this. If I pick up here, A has happened, it means that I can take this X. This X is not necessarily inside it. But in here it says that I am picking up a value in here, let's call it Y. No matter where is this Y, definitely the Y is inside A. Because Y must be also inside A. So this, we can generalize this term. If A is a subset of B, if A is a subset of B, then probability of B given A is always equal to 1. As I said, we will get back to this with more numerical examples. And is there anyone who has never seen the Bayesian rule before? Have you seen it before? Okay, so as you see, this is something that we already knew about it. But this is very important to know how we can interpret the Venn diagram in order to answer the questions. Because sometimes what happens that in many examples in the computer science, we are provided by a Venn diagram like this, or easily we can draw a Venn diagram. In other words, visually we have it in our hand. So we have to be able to interpret it. Later we will talk about more complicated way of probabilities and representation, and we will see if we represent it by a Venn diagram, easily we can understand it. Of course, Venn diagram is not the only visual way of representing the probability and solving it. We will talk in this course about a microchain. We will talk a lot about microchain, and you will see that the microchain also use the state machines in order to represent the probability. So visualization always helps in order to calculate the probability. Do you have any question regarding to this? So let's get back to our slides. Okay. Okay, we start by this slide and we talk about the Venn diagram. We talk about the Venn diagram, we saw that how useful it is. Now, we continue by defining a few more and reminding you a few more things. And one of those things is a random variable. Now, what is a random variable? What is random? What do we call random? What is randomness? What is randomness?
Not so concrete.
Murtaza, what is random? What do we call something to be random?
I think it doesn't have any specific pattern.
Something that we are not certain about it, right? We have some uncertainty about it. So it's called random. So, in other words, it can happen, but not necessarily. So, what about a variable? What is a variable? What is a variable? What is a variable? Variable is something that varies. It's not fixed. Right? Now, let's see how we want to relate these random variables, the variables which the numbers are changing and we don't know if they are happening or not, into the probability. Random variables, as you can see, are basically functions. Because before in the real analysis you have heard that a function has variables, input parameters and output parameters. Now, random variables are type of functions which we are assigning some numbers to some events. In other words, we have some probability events. Now we are assigning numbers to that. For example, assume that we have the coin, our coin, that we were talking about it yesterday. And we said that the coin has a head or tail. So I define a random variable that says head is 1, tail is 2. Now why do we need a random variable like that? Because it is always easy for us to manipulate the numbers, represent them in a graph, represent them on X and but it's not easy to do it if we don't have a numeric variable. Here the examples are mapping the faces of a dice, which is 1 to 6, into the natural number, or mapping the height of a man into the interval of numbers that we have in like this, from 0 to 2.5, assuming that we don't have a man who's taller than 2.5 meter. Can you tell me that what is the difference between these two?
One is discrete, the other one is...
Yes, this one is discrete. In other words, we have the numbers that we are mapping 1 to 6. 1.5 is not defined. 2.5 is not defined. But here, any number is valid. Okay, we are assuming that if this one starts from 1, so we don't have any more shorter than 1 meter. But this, any number is valid. We can have someone which is 1.37, and then we can have someone which is 1.36, or we can have someone which is 2.01. So it means that this is continuous. The reason that we put these examples is in this course we want to talk about the discrete random variables and continuous random variables. How do we understand that something is discrete or continuous? What is the main difference between a discrete variable, random variable, and a continuous random variable?
I think the discrete variables can change instantaneously. I mean,
how do you understand something is discrete and something is continuous?
When it has finite number of values.
Yes, if we have finite number of variables, then we call it discrete. This finite can be 1 billion, but we can count it. 1 billion is a number which we can count. But if we cannot count it, if the numbers of elements is infinity, then we can consider it continuous. So number 1 to 1 billion is discrete, but the interval between 0 and 1, if it is like floating point, then it's infinity, it's continuous, because we have infinity many numbers between 0 and 1. So this is something that we have to be very careful. Now the examples that we see in the class will be a dice, coin, and as the discrete ones, and temperature or height or length as the continuous one. In the reality of the computer science, because we are using computers and everything is digitized, we are dealing with the discrete random variables. You have a pattern, you want to do some matching, then we have these discrete patterns. Now let's continue. We're talking about the discrete random variables. As Morteza mentioned, a discrete random variable, it means that it is finite. We are mapping the random event that we have into an axis, into a numbers which we can count them. They are countable, so they are discrete. In order to show them, in order to represent these discrete random variables, we are using a function which is called the probability mass function. Let's see what's the probability mass function. Now, what was the probability of head? What is the probability of tail? 1/2. Now, what is the probability mass function, PMF? PMF is this. The x-axis is my random variable, and y-axis is probability. Now, can you tell me what are the random variables that I have? 1 and 2. So 1 and 2. And what are the probability values? Half. Now, it's easy to see from the graph that these are discrete, because we know that in a continuous graph they have to be connected. Now when we have the S bars, so it means that this is discrete. This is what is called probability mass function. Now, representing a random variable with a function is always good, because now we have a model in front of ourselves, and we can use mathematical tools in order to develop some stuff. Now when we have the function, we have to talk about the characteristics of these function. Now, what are these characteristics? We know that because in this example, head and tail are the only possibilities. What is the addition of the all probabilities? 1. Because we know that the probability cannot be more than 1. Addition of the probability means that what is the probability of having head or tail? So it doesn't matter if it is head or tail. What is matter is that we have head or tail in our hand. So if I toss a coin and I look at it and I tell you that what is the probability of having a head or tail, it will be 1. We are assuming that the coin will not sit on its edge. So if I have more than 2, let's say consider the die. We have a die and we roll a die. And then we have the number 1 to 6. Now answer my question, what is the probability of having a number between 1 to 6? 1, because it means that if I have any of the numbers, it is correct. In other words, if I had all the probabilities, which is 1 over 6, then I will get the number 1. So this is a generalized formula. If I have a PMF, if I add all the numbers, I have to get 1. So this is a useful equation if I have 4 random variables and I give you 3 of the probability values, you can calculate the last one. How? You know the addition of all should be 1. So you can calculate the value. Another thing about this PMF is these events are disjoint. Do you remember what was the meaning of disjoint? Teshman, what is disjoint event? If A and B are disjoint, what does it mean? There is no intersection. They cannot happen at the same time. If I toss a coin, I will get a head or tail. I cannot get head and tail at the same time. So, in probability mass function, all the events, if you pick up any 2 events, they will be disjoint. So, probability of xi intersecting by xj is 0 if I and j are not equal to each other. So, this is very good. Why this is very good? Because if I have the union of any 2, I can simply add them. I don't have the minus the probability of intersection because the intersection is 0. You remember the formula, right? And another thing is the probability of union of all the terms will be 1. So we will now prove this one, which you might already know. Probability of x1 union x2 union xk is equal to probability of x1 union which is the probability of x1 plus probability of x2 union to xk. What is the intersection of x1 and the rest? Zero, because we said that any xi and j, they don't intersect with each other. Any xi and xj, they don't intersect with each other. So we don't write the minus intersection because it is 0. This is equal to probability of x1 plus probability of x2 union x3 union to xk which is equal to probability of x1 plus probability of x2 plus probability of x3 union to xk. And we know that x2 is not intersecting with any of them. So I can continue and put all of them out, so it will be probability of x1 plus probability of x2 plus the probability of xk, which is the summation of over k of p of, it's over j of xj's. J is starting from 1 to k. What is this? 1. So, probability of union of all the terms is equal to 1. And this is a proof. Any question? Okay. When we have the discrete distributions, discrete random variables, we are talking about this PMF. This is a function, but some of these functions are very famous. One of the most famous one is the uniform distribution. Now let's see what is the meaning of uniform distribution. What is the meaning of uniform? Honest? If something is uniform, what does it mean? What is the meaning of uniform?
When all the possibilities have the same.
Yes, when everything is equal, we call it uniform. If I have a coin and I want to toss a coin, is it uniform? Yes, because head is 1/2, tail is 1/2. But if I tell you, you know that I am a magician and I have a special coin, and the head is heavier, so when I toss it, let's say the probability of head is 3/5, and the probability of the tail is 2/5. Now tell me, is it uniform? No, because the probabilities are not equal to each other. I have a die, and I throw a die. Is it uniform distribution? Yes, because as far as I have not put any condition, the probability of everything is 1/6. So uniform distribution means that if we have n events, so we will have n random variables, which we represent them as x1, x2, and xn. So if we have a uniform distribution, this means that the probability of xi is equal to one of these values of 1 to n is 1/n. The probability of x is equal to x1 to n is 1/n. As an example, the coin. As an example, the die. So the probability is 1/n. So it's easy to see that the summation of pxi's, I starting from 1 to n, is like the summation of 1/n plus 1/n plus 1/n. How many times? N times. So it is equal to n multiplied by 1/n, which is equal to 1. And we knew that the summation, based on the definition of the PMF, the summation of all the probabilities is equal to 1. In the uniform distribution, we have seen that the summation of the probabilities is 1. As an example, as I said, the die, the coin. Or here we have an example saying that we have a box and we have lots of colorful balls. Probability of picking of any of these balls is equal to each other. Now, another distribution is called a binomial distribution. Now, this binomial distribution is a little bit tricky. In this course, we will solve, and you will see, or maybe you already have seen, examples which, when you look at it, it's not binomial distribution. But when you start to interpret it, you understand that this is a binomial distribution. distribution. Let's define what is a binomial distribution. Binomial. What is the term binomial means? Binomial. Do you know the term binary? What is binary? 0, 1, base of 2. So, what is the binomial? What do you think binomial is? We can have only two statuses, two outcomes. So, if you can define your question in a form that you have only two outcomes, and usually we call it success or loss, failure. So if you can divide the question in this form, then it means that the distribution can be represented as a binomial distribution. Remember, it doesn't mean that you cannot have more than two outcomes. Let me write in this form. Binomial means that the outcome is either success or failure. But let's see how I can represent a die as a binomial distribution. Consider we have the dice, and what are the outcomes? This is the sample space, right? This is the sample space. Now I defined my event to have a prime number. Now, to have a prime number, I can always interpret it in this form. I die a die. Is it a prime number? Yes, which is success, or no, which is a failure. You have a mobile phone, okay, and you want to see what is the probability of making the connection. You can assume that it has a Poisson process. It's a Poisson process generally when we are talking about this mobile communication. But we can either make the connection or not making the connection. So we have success and failure. So we can always represent things as a binomial. That's why the binomial is very important, because formulation is quite easy. You can write a computer program that you calculate it. And we can find many examples which you can easily fit it into the binomial. Now, how can we calculate the probability of, let's say, success happening is the n over I. Do you know what is this? The combination formula? Do you remember it? N I, combination of n and I is? What is that? I factorial, n divided by n factorial by n minus I factorial, right? P is represented as success. P is success, usually the notation in probability books. And Q is failure. P is success, Q is failure. One question. Can you tell me that what is P plus Q? 1, because they are disjunct. If you are successful, you cannot be a failure. So this means that I can always say Q is equal to 1 minus T. That's why in some books you will see that it's written as combination of n and I, P I, Q to power n minus I. Or like in here, you will see that P to power I multiplied by 1 minus Q to power n minus I. This is what is called failure, and this is the probability of the success. As an example, it says toss a coin 4 times, the probability of appearance of page twice. We will solve an example, numerical example, soon. Now, before we do an example of the binomial, let's look at these sample examples for a discrete random variable with a uniform distribution. This is our favorite die. We said that the die, we have 6 sides, so we can map each of these sides into a number. So 1, 2, 3, 4, 5, 6 are representing to which side has happened. Because the die that I have in my hand is a uniform, is unbiased die. These are the terms that you have to be careful. Unbiased means you can treat everything equally. So it means all the probabilities are equal to each other, and based on the formula it is 1 over n, which is 1 over 6. And the summation of all of them is 1. But if I have a bias die, then it means that these probabilities are not equal to each other. Maybe the probability of having one of the numbers is bigger than the others. If I have, let's say if I have an unbiased die in my hand, and I roll it, and I get all the values, or it's given, can you tell me that in case of unbiased, it's not biased, in case of having a biased die, what will happen to this formula? Yes, even if it is biased, in other words, probability of having 3 maybe is 3 times more than the other ones, the summation of all is still 1. Because if this increases, it means the other ones will decrease. The summation of the whole probabilities cannot become more than 1. Remember, no matter if it is biased or unbiased, all of them are disjoint. All of them are disjoint. In other words, if 3 happens, 2 cannot be happening. Here you see the tabular form of these probability mass functions for the die. Now, we talk about the discrete terms, a die, so it has a value of 1 to 6, and we couldn't have 2.5. Now, what will happen if we have a continuous form? If we have a continuous form, the probability mass function will be changed into something which is called probability distribution function, PDF. The formulation will not be changed because the nature of the event will not be changed. Though we are from discrete, we go to the continuous, and you will see that the formulation summation will be changed into the integral, but the summation, the addition of all the probabilities, though we have infinity many, it cannot be more than 1. So let's see how we can calculate these probability distribution functions, the PDFs. A PDF, as we are expecting, is continuous. So before in the PMF, we have lots of bars which were representing that they are discrete. We couldn't have a value between, let's say, 1 and 2. But here, we have a continuous function, which means anything is possible. Now, one question. This is my PDF. So what PDF says is the probability of x between x1 and x2 is equal to, the probability is this, the area underneath this graph. What was the formula for area underneath the graph? Is integral, and let's call this one f of x dx from x1 till x2. This is what you may know from the area calculus, that And if you want to calculate the area under this graph, we need to take this integral. Now, question. What is, we are in the continuous, what is the probability of x is equal to x1? What is the probability of x is equal to x1? What is the probability of x is equal to x1? 0. Why it is 0? Because we can write in this form. It is the integral of x1 to x1. Why? Because this is the probability of x is greater than x1 and less than x1. Equality means this, right? Of fx dx, and from calculus we know that is equal to 0. So in the continuous form, the probability of having one event, one point is always 0. That's why that here, it doesn't matter if you put equalities or if you don't put the equalities. Usually we do, but it's not important to put it. So probability of one point from the calculus, remember, it is 0. But usually what we do, we are calculating it. If you want to know what is the probability of x from x1 to x2, we take the integral. In the PMF, we said that the summation of all the probabilities is 0, is 1, right? The summation of all the probabilities is 1. You have a die, and the probability of each of the faces is 1 over 6. So addition of all of them is equal to 1. In the continuous form, how we represented is this. The integral from minus infinity to plus infinity is equal to 1. Now, integrals are not very easy sometimes, right? I mean, you have to find the equation, you have to know the equation, you have to take the integrals. In the exam, if there is a very difficult integral, it will be provided to you what is the result of the integral. I will give you a data sheet, and I'll tell you that what is the integral of, let's say, a sine and cosine, if it is required. But what you need to know is the integral of the polynomial. Do you remember integrals of polynomials? Unless you remember. There are a few proofs. This is a reminder from the calculus. Integral of x to power n dx is n plus 1 it's 1 over n plus 1 x to power n plus 1 plus a constant c. And if we have it as from A to B, you just substitute A and B. You don't need to put the constant C. In the exam, if you are doing something symbolic and you forgot this C, although in the calculus they will cut point from you, but here it's not a calculus course, it doesn't matter, because usually we have the boundaries and this constant will be always cancelled. Now, another formula that you have to remember is this. A x to the power n plus b x to the power n dx is equal to a integral of x to the power n dx plus b integral of x to the power n dx. In other words, integral is a linear operation, which of course in the exam you can do it in one line and write it as a over n plus 1 x to the power n plus 1 plus b over n plus 1 x to the power n plus 1. And of course, as I said, there is this c, but usually because we have the boundaries, we don't use it. So this is the integral that you have to remember. plus one more integral. This is true. Do you remember what's the condition for this one? This formula is always true except if n is equal to -1, this is not true. So I have to tell you what will happen if x is equal to -1. Have you finished writing of this? If n is equal to -1, we have x to the power -1, which is 1 over x. So the integral of dx over x is equal to ln of x plus c. The rest, if it is required, I will give you. However, we always remember this important thing, that the integral from x1 to x2 is the area underneath the curve. Sometimes the curve that we have is a very nice and friendly curve. In other words, I give you this. This is one thing. This is x1. This is x2. This is x3. And this is x4. This is A. And this is B. Now, question. What is the probability of x to be between x1 and x2? What is this probability? On this graph, it is this area. Right? So one way is this. Integral from x1 to x2 of, let's call this one Lx dx. This is the real way. What you have to do, you have to calculate the equation of the line and put it in here. However, we know that this is the area. What is this shape in geometry? It's triangle. What is the area of a triangle? The height. What is the height? A. Multiplied by the width, which is x2 minus x1, divided by 2. Finished. So this is the probability. So you can either calculate the equation of the line, you put it in the integral, you take the integration, you put the values and you calculate it, or you simply say that based on the geometry, what is the value, you put it in here. What is the probability of between x1 and x4? If you want to calculate it, you can use the geometry, or you can use the what is called the equation of the lines. Or what is this? What is the given that probability of x less than x1 is 0 and probability of x greater than x4 is also 0. What is the probability of x in between x1 and x4? What is it, Murtaza? 1. Because you know that the integral of all the probabilities should be, look, question is this. What is the probability of x being between x1 to x4 of, let's say, fx dx, whatever that is. And because we know probability of x less than x1 is equal to the probability of x greater than x4 and is equal to 0. This is given in the question, we assume. So this is equal to, I write from minus infinity to x1, fx dx, we should do that this is 0, plus x1 to x2 of fx dx, plus x2 to the infinity of fx dx, and we know that this is 0. Now, these are the same, so I can join it and write it minus infinity to x2. x2's are the same, so I can write it as minus infinity to plus infinity. So I can write it as minus infinity to plus infinity of fx dx, and we know this is the property of a PDF. And it is 1, because adding of all the probabilities is equal to 1. And in case of continuous form, integral of all the probabilities is equal to 1. What I have done in here is this. Integral of a to b of fx dx plus integral of b to c of fx dx. This is equal to integral, these are the same, so I can cancel it and I write it from a to c of fx dx. So here x1s are the same, here's x2s are the same, so it will be from minus infinity to plus infinity. Why? Because from minus infinity to x1 is already 0. So adding 0 to something is not changing anything. Afterwards is also 0. Adding 0 to something is not changing anything. So I can add it. So I can write it in this form in order to show that this is the results. What will happen if we are in the previous example, we are between x1 and x2, x4. Now, do you have any question? What we're going to continue our talk, is talking about something which is called cumulative distribution function. What is the meaning of cumulative? What is the meaning of cumulative? Sorry?
Addition.
Yes, addition. Cumulative means that you are always adding something on top of what I have. So, cumulative parallel distribution function, as the definition means, is this. Definition of f of b is the probability of x is less than equal to b. Now, let's see what visually it means. What is the meaning of cumulative distribution? Means the probability of x is less than b. We remember what was the probability of x between a and b. What was it? It was the integral from a to b of fx dx, right? Right, Anas? You remember it? In the previous slide. We said the probability between a and b is this integral from a to b. Now, what we have, probability of x is less than b, which means that x is between minus infinity till b. So it means it is equal to integral from minus infinity till b of fx dx. On the graph, it means the area from minus infinity till the point v. So it means this integral, or on a graph, it means this. This is when we have a continuous form. This is when we have a continuous form. Now, what will happen if we have a discrete form? If we have a discrete form, it means that the probability of x less than v and x is greater than minus infinity still. And it will be the summation or x i's, I started from minus infinity till number v. Or if we have started from 0, it will start from 0. If any probability before 0 is 0, we don't use it. But in general, this is the formulation. Either we add from the beginning, from the very beginning till where we want, or we are integrating it if it is a continuous random variable. So we are calculating the summation if it is discrete, and we take the integral if it is continuous random variable. Now, calculation of the cumulative distribution is very useful. We use it in order to define transform functions. I can give you an example in image processing. For instance, if you want to use something which is called histogram equalization, you need to use the cumulative distribution function of an image. So it will be very useful and very meaningful. Now, I have calculated if I know the PDF, I can always calculate the CDF, the cumulative distribution function, CDF. But what will happen that in a question or somehow through my data, I know the CDF. How can I calculate the PDF? This is very important. In other words, I have this result, I have the capital F. How can I calculate the lower f? Which I am sure that you know the solution already from the calculus. If fx of v is this, if capital F is integral of lowercase f, how can I calculate the lowercase f? If integral of lowercase f gives me capital F, how can I calculate lowercase a? Murtaza?
Like the first derivative of...
Derivative. Then f of x so this is okay if I have this continuous form. If I have the continuous form, right? What about if I have a discrete random variable? How can I calculate p of x is equal to v? This was alright for the continuous form. We knew the derivative. We have the function, the cumulative distribution function. I find its derivative and I have the CDF. I have the PDF. Now, what will happen if I have the cumulative distribution function for a discrete random variable and I want to calculate the probability mass function? What is an equivalent of differential equation in the discrete form? It's difference, and it will be f(x) of v minus f(x) of v minus 1. In other words, what is happening in the discrete cumulative function? Always I am adding the values, right? Always I'm adding the values. So you will see a graph like this. Always I'm adding something. I want to know that at point V, how much I have added. I have to find this difference, right? Because how much do I add to this to get to this one is the probability of V, which is this. How can I calculate it? I can find the difference between these two. This is what this formula tells you. Because if I have the PNF, What is the CDF of this PMF? The first one is the same. For the second one, I have the second probability on top of this one, so I get this. Then I have the next probability and I get this. So, do you notice something? Can I have a CDF? It doesn't matter if it is continuous or discrete. Can I have a CDF which looks like this? This is the beginning. Why? Why this is not possible?
Because the addition, you cannot add two probabilities and get a lower.
Why?
Because they are from 0 to 1.
Because they are all positive. I cannot add a positive number to this and I get a lower value. What about this? They are equal. What about this? Is it possible? We can consider those as a continuous function. They are equal. Is it possible? Nice. Mortaza?
Yes.
How come it is possible?
If the probability of the red one is 0.
Yes. If the probability of red one is 0, it means that after this one I have added 0, so I get the same value. What does this mean? This results into a very, very important conclusion. CDF, I am not mentioning if it is continuous or discrete, is a non-decreasing function. In other words, it can be, we have probability 0, so the values can be the same, or it has to increase. It is not possible to decrease. It is not possible to decrease. Why? Because probability is always non-negative, which means 0 or positive number. So either we are not changing or we are adding. It's not possible to decrease. So CDF is always positive. And we have found how we, if I know the CDF, how we can find the PDF. If it is in a continuous form, I find the derivative, and if it is in a discrete form, I use the difference. Here, the formula that I just mentioned, in order to calculate the CDF, what we do, we integrate from minus infinity to the point that we wanted to calculate. This is my guy, and it is an unbiased guy. What is the name of this graph? What is it called? This is what was PMF? Probability mass function. This is the PMF. Because it's the random variables that I have, and it shows the probability value assigned to each of them. Now I want to calculate the CDF. Now, if you notice based on the definition of the CDF, I am not talking about the CDF of x is equal to 3. It's meaningless. CDF means that what is the value if x is less than or equal than the 3? So we always start from minus infinity and we go to that point. Now, the first value is 1, right? Before 1, what is the value of the CDF? let's say, if the value is 0, if the random variable is 0, what is the value of, what is the f of x is less than equal than 0? What is it? It's the summation I from minus infinity till 0 of p of xi's. Can you tell me what is the probability of x to be 0? 0. X to be minus 1? 0. So from minus infinity to 0, all the numbers are 0, so this is 0. So here it is 0. Before that it's all zeros. Right? So before that all is 0. We come to the number 1. What happens for the 1? This is 1, and I calculate it till 1. I know from minus infinity to 0 is 0. This is plus the probability of x1. What is the probability of x1? 1 over 6. So 0 plus 1 over 6, it will be 1 over 6. Now, for the next one, 2. I have to start from minus infinity. I know from minus infinity to 0 it is 0. Then I have to add the probability of 1 plus the probability of 2. So what is it? What is that?
2 over 6.
2 over 6. 1 over 6 here plus 1 over 6 in here. So this one will be added with this one, so it will be 2 over 6. The next one, 3 over 6. 4 over 6. 5 over 6. 6 over 6. Now, question. What is the probability of x is less than equal than 7, which is the summation from minus infinity to 7 of p of xi? What is it? It will be 1. Why? Because from minus infinity to 0, 0. We don't need it. From 1 to 6, if we add them, we will get 1. From 7, afterwards is also 0. But 1 is 0 plus 1 plus 0, it will be 1. In other words, afterwards, for all the values, this is 1. This is 1. In other words, if this was a continuous formulation, if this was a continuous case, then you would see that the graph will be something like this, for instance. Of course, this is a discrete CDF, but if this is a continuous form, you will see that after we reach the maximum, be continuously 1. In other words, it cannot increase because the summation of the probability maximum is 1. This is very good in order to check if you have done all the calculation of probabilities correct or not. Why? Because by the last term, the value of the CDF must be 1. If it is not, then it means something is wrong. Or if it is above 1, then it means it is something again wrong. But what will happen after 6? Nothing can happen. What is the probability of 7? H1? What is the probability of 7? 0. 8, 0. So I am not adding anything to this one. From this one, I'm adding 0 always to the last value. So it will continue like this. So here we can see the CDF for a dot. This means, this graph means, from this graph what we get, f of minus infinity is equal to 0, f of plus infinity is equal to 1. Here we know that from minus infinity to 0 is actually 0, and here we know that from 7 to plus infinity is actually 1. In other words, there are some properties that they have to know. It is always non-decreasing because probability is either 0 or positive. At minus infinity we have 0 because we don't have anything. And at plus infinity we have 1 because everything has happened now. And it is right continuous. We don't talk about right continuous and left continuousness. Do you have any question? If you have no question, we stop here and we will continue by talking about famous density functions again in the continuous form now, but in next lecture. The slides are available in module. I have updated them. Still, we are reviewing the probability things that you have to know. If you knew it, so it can be a little bit boring, but if you didn't know, it will be a good revision for you before we start the actual course. Do you have any question?